Fritz Haber, the same chemist who saved Germany's munitions industry by developing a method for artificial nitrogen fixation, also worked to make explosive munitions obsolete, and earned himself the nickname the father of modern chemical warfare. It was another German chemist, Walter Nernst, that first suggested the use of choking gas to break the deadlock created by trench warfare. Despite the existing treaty forbidding the use of poison weapons in war, and the misgivings of many among the German general staff, Haber directed the release of 171,000 kilograms of chlorine gas toward the Allied lines during the Second Battle of Ypres in April 1915. Because it's heavier than air, the gas seeps into the trenches, attacking the eyes, noses, and lungs of the French, British, and Canadian soldiers. Nernst and Haber would both be awarded Nobel Prizes for other contributions to chemistry. In fact, there were no fewer than 5 German Nobel laureates in chemistry on the field that day, assisting in the release of toxic gas. A solution is saturated if it contains the maximum amount of solute that it can dissolve. For example, 1 liter of water can hold around 360 grams of sodium chloride at room temperature. Any more than that will not dissolve, so 360 grams per liter is as salty as water can get. Chlorine gas is produced at the industrial scale by running a current through salt water. This generates chlorine gas, hydrogen gas, and sodium hydroxide, NaOH. If we begin the process of producing chlorine gas with 10 liters of saturated salt solution, how much chlorine gas can we make? Which of the reactants, either salt or water, limits the maximum amount of chlorine gas? That is to say, which one is the limiting reagent? First, we need to determine how many moles of each reactant we have. We're given the volume of water, which we can convert to mass by knowing that there's 1 kilogram per liter of water. We then divide it by its molecular mass to find the moles of water. Then we do the same thing for sodium chloride. Now that we have the moles of each of the reactants, we need to use the balanced chemical equation to find the stoichiometry to let us know how much chlorine gas each of these reactants could produce. Whichever reactant can produce the least amount of chlorine gas is the limiting reagent. Because the amount of sodium chloride in solution can produce less chlorine gas than the water can, it is our limiting reagent, and that is the maximum amount of chlorine gas that we can produce. So what if we had put in more than the saturating amount of salt into that original 10 liters of water? What would happen to the undissolved salt as the dissolved salt started to turn into chlorine gas? This is an equilibrium problem and will be the subject of our next video.